Okay, welcome. This is lesson 36. We are multiplying and dividing integers, multiplying and dividing terms. What's our objective? Get ready?
Multiplying and dividing integers,
Multiplying and dividing terms. Good. Last week we added and subtracted negatives and positive integers. Today we're going to multiply and divide. We're also going to learn about the principal square root, and we're going to be doing the distributive property with terms, with negatives and positives. So let's just do a quick review. The general rule for positives and negatives are negative times negative. Remember, this is times, not add or subtract. A negative number times another negative number is positive. Positive times positive is positive. If the signs are different, the negative wins. Negative times positive is negative. What?
Negative times positive equals negative.
Good. Positive times negative equals negative. What?
Positive times negative equals negative.
Very good. If the signs are different, the answer is negative. Except the negative wins out, unfortunately. And then if the signs are the same, they're agreeable. Think about, oh, they agreed with each other, so they're happy, they're positive. So if the signs are the same, it's positive. What?
Positive.
Positive. So let's try some practice problems. I've got a positive times a negative. What's the sign of my answer, think? You ready?
Negative.
Negative. Negative times positive. What's the sign of my answer? Get ready?
Negative.
Negative. Negative divided by a positive, it's the same rule. So I could change these into a division, and it'd be the same rule. So negative divided by a positive is, think? Get ready?
Negative.
Negative. Good. Let's make sure everyone's repeating back so that I know you're with me. Negative divided by negative. What's the sign of my answer, think? Get ready?
Positive.
Positive. Good. And then to just so we know the answer, 2 times 3, and 6 divided by 3, 6 divided by 2. All right. So same sign is positive, different signs is negative. Yes, Colin.
Well, you can remember it is like think of them as cats and dogs.
They fight.
Yeah. So if they're the same, they like each other, so it's positive. But if they're different, then they hate each other, so it's negative.
I like that. A cat and a cat, they get along. It's all happy. A dog and a dog, they're happy. Oh, dog and cat, they fight. Dog and cat. I like that. I'm going to use that. Thank you. Okay, we're going to do this as a class. Let's answer again. See, can we do the sign and the answer? Can we do that? So negative times negative, what's the sign and what would the multiplication be? Get ready?
Positive 50.
Good. Positive 50. Positive times negative, what's the sign and what's the product? Get ready?
Negative 50.
Excellent. Thank you for staying with me. Negative divided by negative, think. Get ready?
Positive 2.
Awesome. And positive divided by negative, think. Get ready?
Negative 2.
I love that you guys are staying with me. Thank you. I'm going to skip that one and we're going to go right into this one. Powers, exponents. How do I handle positive negatives when I have an exponent? So my base is multiplied by itself 2 times. Negative 5 times negative 5. I have a lot of people who think, well, isn't it 5 squared and then I just make it negative? No, because it's negative 5 squared. So negative 5 times negative 5. So I've got negative times negative. What's the sign of my answer? Get ready?
Positive.
Good. Positive, and 5 times 5 is 25. How about this one? Negative 2, negative 2, negative 2. Well, it's easiest when you have more exponent, or a higher power, to pair them up and just do 2 at a time. So negative times negative is positive. 2 times 2 is 4. This one's going to be a negative 2. And again, I'm not adding, I'm timesing. Positive and negative. What's the sign of my answer? Get ready?
Negative.
Good. And then 4 times 2 is 8. So I think maybe we're going to come up with a little pattern here. We might have to take a couple more till we really see the pattern. Can we do these in pairs, the negatives in pairs? Positive, positive. Ah, darn, there's one more negative. It's a dog, came to play with the cats. So the sign of my answer is going to be, get ready?
Negative.
Negative. So I had this one, and then they're all 1, so it's negative 1. What about the 6th power? Are we seeing a pattern? Does anyone see a trick or a pattern? A lot of you do. And I saw Ethan's hand up a while ago. I think you knew it. What is the pattern, Ethan?
I was going to say that if the exponent is, what's the word? Is it, yeah, even? If the exponent's even, then
Very good. And as long as if we're talking about the negative base. So he says if the exponent is odd, there's going to be one extra negative. So it's going to have to be a negative answer. If your exponent is even, all of those evens are going to cancel each other out. And so you have to have a positive answer. So an even number will kind of get rid of that negative number in the base. Okay, very good. And if you forget that rule, just expand it out, pair them up, and you can see what the sign of the answer will be. Let's talk powers for finding roots. Get all this off. All right. For y equals x squared, find y if x is negative 2. Let me make that a little bigger. So what this means is solve for y if I let x equal negative 2. So I'm going to rewrite my equation. And instead of writing x, I'm going to write negative 2. So negative 2 instead of x, square that. Oh, we just did that. Negative 2 times negative 2. Negative times negative is positive. 2 times 2 is 4. My answer is 4. So, but wait a minute. I thought 2 squared was also 4. So you're saying that a 4, I could have had a negative 2 or a positive 2 give me the same result as far as squaring something. That leads us to the next question. If some number squared equals 9, what are the two possible answers for x? Jasmine?
3 and negative 3.
She says 3 because 3 squared is 9. True. And she says negative 3 would also give me a 9. So I could say x could be 3, but it could also be negative 3. So mathematicians came up with a cool way to write that, which is going to be brand new for you guys. Plus or minus 3. How do we say it? Get ready?
Plus or minus 3.
Plus or minus 3, because both answers, the plus 3 or the minus 3, would be would satisfy this equation, right? Okay. If we're talking the square root of 9, if I went to x squared, whoa, equals the square, whoa, okay, x squared equals 9, and I wanted to take the square root of both sides. If I was only interested in the positive answer, because I was maybe talking about the length of a hypotenuse, and I don't care about the negative one, I would say, what is the principal square root? The principal square root is the positive root. What is the principal square root? Get ready?
Positive.
The positive square root. So positive is the principal square root. Rachel? Okay, so let's talk, what if we have several variables and exponents? 6x squared y times negative 2xyz. Now, something about this is you're looking at it going, oh, I thought we did that last week. There's no like terms. I can't add those. Are we adding? No. Are we subtracting? No. There's parentheses. So right there is a times. This is a times. That's a times. There's a times, a times, a times. Everything is a times. There's no adding or subtracting, so it follows different rules. If you're multiplying, we have the commutative property. Commutative property says in multiplication I can change the order. What does commutative say? Get ready? Change the order. Meaning I could change the order and I could put the negative 2 next to the 6 just because I want to put all the similar things together. They're timesing, right? Timesing. I can put my x squares together because I can change the order. I can commute this one over here. I could also put my y's together, commute them together. They're timesing. And then I have just a loner z. Now that they're together, why would I do that? Because now that they're together, I can combine them easier. I can see it a little easier. Once you get more advanced and you can see it without having to write it, I'll let you skip this step. But for right now, write the step. 6 times negative 2 is negative 12. X squared times x to the 1. How many x's is that? Okay, ready?
3.
3. So I write x cubed. Y times y is y squared. I just leave z alone. I really don't have to put my dots, but it's certainly not wrong if I leave them there. But the most simplest answer is that. Any questions? You're going to do one now, but you're going to divide. So when you divide, I want you to expand the numerator and then cross-cancel any terms that are the same on top and bottom. Divide your coefficients. Write it on your paper. Put your pencil up when you've got it. Okay? So I divided 6 divided by -2. I get a -3 out of that. Now I'm going to expand the top. X times y. That's the numerator. On the denominator, I get x, y, and z. Now be careful. If it's on the numerator, it has to stay on the numerator. If it's in the denominator, it has to stay in the denominator. The only thing I can get rid of are things that turn into 1. In other words, the same number on top and the same number on bottom. So x over x turns into 1. X over, nope. How about y over y? Y over y turns into 1. So now I'm just going to rewrite what's left. -3 is on top. There's an x left on top, and I have a dividing line, so I can't get rid of that. And z is in the denominator. Where is the z? Get ready?
Denominator.
Denominator. And so it's kind of different than what we've done before, but that's the mathematical way to do it. Okay? So we canceled. We keep things on the top and bottom where they go. We simplified. All right. Who remembers the distributive property? A times, parentheses, B plus C. What would that equal? Kaylee. AB plus AC. Excellent. What does it say, class? Get ready?
AB plus AC.
AB plus AC. I should have moved it up just a little bit. So what we did to get that is we took our A, we multiplied it by B, then we added A times C. We're going to do the same thing now with some bigger some bigger terms. Before we just had like a number like 2 and like x. Now it's like 3x or a negative something. So we're going to take 3x times it by 2x. And 3x times 4, and we're going to put a subtraction between the two of them. So, didn't I just say 3x times 2x? I'm going to write what I just said. 3x times 2x. Then I'm going to minus 3x times 4. Well, I'm going to write what I said. 3x times 4. Everything is being multiplied, 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 multiplied. That's the only thing that's being subtracted. My last step is to clean it up or simplify. 3 times 2, I could group them together. Can we skip that step and just say 3 times 2 is, get ready?
6.
X times x, think. Get ready?
X squared.
Awesome. Everyone thought it was just x in the last class. Okay, good. Because x times x is x squared. And then 3 times 4 is, get ready?
12.
12 times x. And can I combine these two? No, they're not like terms. This one has a squared. This one has an imaginary 1. They're not like terms, so you're done. You can just leave it like that. It's beautiful and perfect. Now it's your turn. Will you expand or distribute this one? It's similar, but it's got an extra negative, and I want to make sure we know how to handle this extra negative. So write this on your papers. Put your pencil up when you've got it. Okay, let's check it. So negative 3x times 2x, negative 3x times 2x. Then I'm going to copy my minus sign down. Now it's negative 3x times 4. Negative 3x times 4. Now give me a nod if you're okay so far on what I did. Give me a nod no if, I don't know how you got that, Mrs. Boone. Okay, let's just check it. Let's see, we got to go this first outside, negative 3x times the first one. So we just wrote down negative 3x times 2x. We're okay there? Okay, and then we're going to copy the minus sign down, take the first term again, and times it by the last. So negative 3x, I copied it right there, times 4. We're okay? Okay, awesome. My next step would be combine, or well, multiply through the like terms. So 3 and 2 would give me a negative 6. X times x is x squared. What about in here? Let's save this negative for last. Let's work on just the negative 3x times 4. Negative 3 times 4 is, think. You ready?
Negative 12.
Good. And then I didn't mention anything about the x. It doesn't go away. We're just going to keep it right there. Okay? But how do I handle this? I have negative 6x squared minus negative 12x. Well, I learned last week a minus a negative, they cancel each other out and become a positive. So my last step is plus 12x. How many of you had negative 6x squared plus 12x? After a little bit of, okay, good. That's not bad. You'll get better at it. Look at this. Step 1, write the problem. Step 2, distribute. Step 3, simplify. Step 4, simplify again. So these are a little tricky to do in your head when you're still learning them, so please write all your steps on your board. Don't erase them. Leave them on your board, leave them in your homework. That's part of our showing of work. Okay, we're on page 241. Here are your problems A, C, E, G, I, K, M, O. Cars 10. You may take a 20-second stand-up break. Library Whisper.